So yesterday in class we talked about basic ratios of trigonometry. I illustrated this to you by looking at our shadows and the way the sun hits us in the middle of the day when we were outside. And so what I wanted to illustrate was that if the sun's rays are hitting me at this very specific angle and creating a shadow, the sun's rays are also hitting Abby at this exact same angle and creating a shadow, and they're hitting Jared at this same angle and creating a shadow. Agreed? So when we realize this, all of these angles, this angle from me to the sun, Abby to the sun, and Jared to the sun, they're all the exact same angles, but when you look at the triangles, they're all different sizes. But what we want to understand is that the ratio of the height of the person to the shadow is going to be the same, no matter how big or tall or short the person is. So when we look at this angle, we can try to find what this exact angle is, but we really don't have to. Understanding that trigonometry is all about similar triangles. Okay? So the ratio of Jared's shadow to Jared is going to be the same as Abby's shadow to Abby, and my shadow, I'm Gia, to me. Okay? So if I look at any of these ratios, I'm going to be able to state this very specific equation, that me to my shadow is going to be exactly the same as Abby to her shadow and Jared to his shadow. Okay? I can also take these ratios and flip them over. I can say that my ratio of my shadow to my height is going to be equal to Abby's shadow and her height, and it's going to be equal to Jared's shadow and his height. So we have this idea of equal ratios, and that's what trigonometry is all about. So what are the basic ratios of trigonometry? Well, we talked about them. We have the sine ratio, the cosine ratio, and we have the tangent ratio. We have these three ratios, and they're all about right triangles. So when we look at the right triangles, the very first thing we have to do is we have to be able to identify the legs and the hypotenuse. The hypotenuse is the side that's opposite the right angle. So I'm going to call this H. So I always want to be able to identify where the H is, because once I've identified where the hypotenuse is, then I can use the sine, the cosine, and the tangent ratio using the idea of the legs. So just to review, we said that the sine ratio, is equal to the hypotenuse, the opposite leg over the hypotenuse. And we said that the cosine ratio, these are all abbreviations, is the adjacent leg to the hypotenuse. And I'm using the word leg because it's important that you don't get your legs and your hypotenuse mixed up. And then the tangent ratio is the opposite leg over the adjacent leg. So now what does that all mean? That means that if I look at a particular angle, I'm going to call this angle X degrees. And if I label each side by its adjacent leg, here's our adjacent leg, and here's our opposite leg. Why is this called the adjacent leg and this is the opposite leg? Because here's the angle, and this leg is right next to the angle. So that's the adjacent leg. Why is this called the opposite leg? Because this leg is opposite the angle that we're looking at. So an equation that I can write is sine X degrees equals the opposite leg over the hypotenuse. And when I have numbers in here, this is all going to make sense, and I'll do that in the second video. In this triangle, it's a little bit more confusing because of the orientation. So that's why we have to really identify where the right angle is. So let's say I call this angle A degrees. I'm going to call it little a degrees. So where is the opposite leg? The opposite leg is across from the angle. It's opposite. So I'm going to call that OL for opposite leg. Where is the adjacent leg? It's right here, right next to it, AL. This guy looks a little weird too, okay? So now, if I have my angle, let's throw a different angle out there. I'll use purple. Let's say we want to call this angle N degrees. Again, try to identify where the opposite leg is and where the adjacent leg is. Here's the opposite leg, and here's the adjacent leg. So using this information, I can write almost all of my trig ratios. But let's just start with sine. So in this case, the sine of x degrees is opposite leg over hypotenuse. In this case, the sine of a degrees is opposite leg over hypotenuse. And again, once we get some numbers in here, we'll be able to manipulate some questions so we can answer some questions. And then here, the sine of n degrees, again, is the opposite leg over the hypotenuse. I can also make all of the other ratios with this. So I'm going to leave that up there. And I'm going to make the other ratios with this. And I'll do this just in blue. Okay? So, what is the cosine? The cosine of x degrees is the adjacent leg over the hypotenuse. Again, where is the cosine? The cosine is the adjacent leg. Cosine of a degrees equals adjacent leg over the hypotenuse. And the cosine of n degrees equals the adjacent leg, the guy next to it, over the hypotenuse. So you see that the ratios are all the same, but the numbers are going to be a little different later on. And the last one, let's put this in purple, the tangent. So the tangent of x degrees doesn't have anything to do with the hypotenuse. It only has to do with the legs. So the tangent is the opposite leg over the adjacent leg. Opposite over adjacent. Opposite over adjacent. So tangent of a degrees, again, it's the opposite leg over the adjacent leg. So the tangent is only about the legs. And in this case, it's the same thing, but we have a different angle measure, n. So the opposite leg over the adjacent leg. And we have a nice mnemonic device to remind us of our trig ratios. Okay? So, sine is opposite over hypotenuse. Ca, adjacent over hypotenuse. Toa, opposite over adjacent. So here's your nice mnemonic device to help you remember these three basic trig ratios. In the next video, we're going to do some problems.